Hi you guys. Today we're going to be going over lesson 914, which is covering angle-angle similarity for triangles. It's a way to prove that two triangles are similar given certain information about the triangles. So here we have two triangles, and you can see they're obviously different sizes. But the angles inside the triangle have specific markings, and this particular angle right here with the little 1 tick mark on it is marked similar to this angle here, which means these two angles are similar or have equal measure. The same is true for this angle that has 2 tick marks on it. It is marked similar to this one, which means the angles are similar or have equal measure. So, angle-angle similarity states that if two pairs of corresponding angles have equal measure, then the triangles are similar. And that's what we have up here. Two pairs, here's the first pair, and here's the second pair that are similar, which means these two triangles are similar to one another. This one is just a dilated or larger version of the first one. Now we're going to work through an example problem using that information that we just learned about angle-angle similarity. Example 1, part A, asks us, are the two triangles similar? How do you know? So we need to look at the information they've given us here. We have a smaller triangle on the left. It's got a base of 4 centimeters, a height of 3. This corner in the bottom right is marked as a right angle or a 90-degree angle, and directly above that is a 50-degree angle. Moving over to the right, we have a larger triangle with a base of 18 centimeters, an unknown height. In the bottom right-hand corner, we have a 90-degree angle, and above that we have a 50-degree angle. So the right angles are already marked similarly, so we know that's one pair of corresponding angles that has equal measure. And then this top angle, the 50-degree angle, also has equal measure. So there's a second pair of corresponding angles with equal measure. So the answer is yes, the two triangles are similar. Because they have two pair, extra S there, two pairs of corresponding angles with equal measure. Part B asks us to find the scale factor of these two triangles. Recall that the ratio for scale factor is new over original. So we are going to compare corresponding sides between the two triangles. Let's call the larger one the new triangle and the smaller one the original. So I see that I know both measures of the base, so I'm going to compare those two. So I'm going to compare 18 centimeters over 4 centimeters. And when I simplify that, 18 divided by 4 is 4.5. So the scale factor between the two triangles is 4.5. The new triangle is 4.5 times larger than the smaller triangle. Part C asks us to find x. Well, this is the side that is labeled x centimeters, and we need to determine the length of that side. Now that we know the scale factor, we can do that. We're going to compare x to its corresponding side that is 3 centimeters long. And of course we're going to show our work because we know that we must do that always when we have calculations. So our original side length is 3 centimeters, and we know that the scale factor is 4.5, so the new side, or x, is 4.5 times larger than the original side. So then we have to multiply 3 times 4.5, and we determine that that is 13.5 centimeters for the length of side x. Okay, we're on to part D, which is the last part of this problem. It asks us to find the area of each triangle. And I'm running out of room here, but we can squeeze it in. Recall that the formula for area of a triangle is equal to base times height divided by 2. So let's take our first triangle and find that area. The area of this triangle is going to be equal to 4 times 3 divided by 2. You can hear my cat has come up to say good morning to me. And when I work that out, I get 12 divided by 2, or 6 centimeters, and that's squared. Area is two-dimensional, so our units are always squared. Let's move on to our larger triangle and find the area of that. I have to say hello to Floyd, or he's going to keep crying. Hi, Floyd. Okay, so for this one, we are going to multiply 18 times the height, 13.5, and divide by 2. 18 times 13.5 is 243 divided by 2. And we find that the area of the larger triangle is 121.5 centimeters squared. All right, you guys, see you for our next lesson, which is 921. I signed off just a little too soon. I forgot to remind you that tomorrow's assignment is review preview problems 945 and 949 for those of you who did the work before spring break and submitted it to me. You only have these 2 problems. If you did not do the work before spring break or submit it to me, then your assignment is the entire review preview, which is 945 through 950. Remember to email me if you have any questions. I'd love to hear from you. Bye.